over it, and that will full screen that window. So now we've got all of the space to. So to start us off, before we do too much making nodes, I'm just going to go ahead and set up our properties. So we've got a list of about 7 properties that I'm going to be setting us up with. The first one is a vector1. We're going to call it IOR, and that stands for Index of Refraction, because the glass is going to have refraction to it, which means it's not just going to show the image straight. The index of refraction is a property that also transparent materials have, and it dictates how much they refract things. So like, when you stick a pencil in a glass of water and it's skewed, it's that. The index of refraction of water determines exactly how much it's skewed. So we're going to be using refraction for this. And we are going to set that up as a slider, because in this thing, the index of refraction, if it gets below a certain value or above a certain value, it starts to look. So if you go to mode, you can click on slider under that. For our default, we're going to leave it at 0. For our minimum, we're going to go negative 0.37. And for our maximum, we're going to do 0.61. Anything past those and it starts to look a little weird. And that's just from my experience messing around with this thing. So our next property is also going to be a vector1. And we're going to call that Fresnel power. So this is going to be the power for our Fresnel node, which we'll be using later. The power for the Fresnel node determines how far or how close to the edge of the object is that it starts to work. You'll be able to see that bit. We're going to leave that default 0 and as is. So that one just gets to stay normal. Does anybody need these numbers before I go ahead and collapse?
We're getting a couple questions. Brandon's asking, why the specific numbers for min and max?
So the specific numbers for min and max are just based on me playing around with the slider on my own time and seeing what numbers look good. Anything lower than about negative 0.37 starts to, I'm trying to remember exactly what it does because it's been a minute since I messed around with it, but it starts to get things in the wrong place or something, and then anything higher than 0.61, I don't remember what it does. When we're done putting the shader together, I can change the min and max values and slide it past those numbers, and I'll show you why it starts to look weird. I wish I had an answer for exactly why it looks weird, but it's got something to do with the way Unity handles the formula, the function that's going into.
Yeah, Josh, stream is good on my end, so I think it's your internet, buddy.
Oh, Daniel, are you recording this for us? That is awesome. Bless. All right,
Thank you, Daniel.
so we've got those 2 properties now, so we'll go ahead and continue with the rest of them. Our third property is its color. So we're going to make a color, and I'm going to leave it named color, and I'm going to leave it in default. Nothing really to change about that. Our fourth property is going to be a texture 2D. So it's basically a picture. That's, spoiler alert, going to be our gradient. And that's not going to need any special defaults either, so that stays as is. Our 4, 5, our fifth one is going to be a Boolean, which is about 2/3 of the way down the list. We're going to call it is iridescent. So, shocker, that thing is going to let us toggle whether or not our glass is iridescent. Iridescent meaning it is kind of rainbow shimmery, which might be where our rainbow texture. So for that one also remains mostly as default. We're going to default it to true, however, because rainbow glass as a default is kind of pretty. Our sixth property is going to be another vector one. We're going to call this noise scale. It's going to scale our noise. And we're going to default that to 10. Our final property is one more Boolean, and we're going to call that uses noise. It's going to decide whether or not our iridescence uses noise to mess up exactly how it's laid out. It randomizes. So that one we are also going to default. That should be our properties. If anyone has missed any of them, let me know.
No one's asked us to slow down.
All right. In that case, we will go ahead and start with actually making the shader. Now this shader is going to use a lot of interesting things, a couple of new things. Not new as in like they're brand new, came out kind of things, but new as in they're not things that are super duper commonly seen, I guess. Or not like things that you'll see on super basic. Hopefully we'll show you guys a couple of scenery use. So we are going to start with creating a node. That's amazing, creating a node. So you can either right click and do create node, or you can just hit the spacebar and the same menu will pop up. So we're going to start with the view direction node. Type that into the search bar and it will pop up view direction. This node, as expected, outputs the view direction of the law. We are going to leave that in world space and I'm going to collapse it to make a little more room. And then to go alongside that one, we're going to add a normal vector node. So the normal vector gives you the normal of each vector in the scene, or of each one that it's trying to. So the normal would be essentially the direction of that. I said vector. It gives you the normal of each. Trying to remember if it's. I think it's vertex. The normal of each vertex. That one is also going to stay in world space. And these we are going to drag both of them into a node called normalize. Normalize takes in a vector and returns it as a length of 1. So just, you guys have used normalize before, I'm sure, in regular coding. So what I'm going to do is I'm going to duplicate that node rather than searching for it and making a second one. So now we've got these two different normalized vectors. Both of these we are going to pull into a very interesting node. We're going to do create node. We're going to do a custom function node. So a custom function node allows you to use functions from the shader graph language, the shader language that Unity uses, is HL. So these are for functions that the shader language is capable of doing that haven't necessarily been implemented into shader graph itself. For this one, we are going to hit this gear button. I'm going to zoom this in a little bit. We're going to hit this gear button, and here we have our inputs and our outputs and our ability to input the function. So you can do this from a file. If you write shader code and save it into a file, you can pull that in here. But what we're going to do, because it's just a very simple one line of code, we're just going to do string. And this lets you write your function in manual. So for our inputs for this, we are going to have one that is a vector 3. And it is going to be, it won't let me rename it. How do you rename this? Okay, give me a second. Wait, maybe that's highlighted. Nope.
Doesn't want you to rename it.
Okay, so this thing is not wanting me to name it for whatever reason. But the first one is going to be for our view. Second one is going to be also a vector 3, and this is going to be for our normal. So those are going to be dragged in from the two things that we just made. And then our third one is going to be a vector 1, and it is going to be our index of refraction. And then for our output for this node, it will output a vector 3. So for the name of our function, we're just going to name it ref. And for the body of our function, it's going to be, I guess that's going to have to, I need this to be able to let me rename it. All right.
Brandon says he's able to rename it just by clicking on it.
Okay. It won't let me rename mine.
Weird.
Okay, so for those of you that are able to rename it, rename your output to out with a capital O, so O-U-T, like that. For those of you that can't, if there's anybody else that can't, like me, then we're going to use the name of this one, which is new space 3 in parentheses. So that equals frac. And for those of you that are able to rename them, this would be your names, which would be view, comma, normal, comma, IOR. But for me, this is going to have to be new 1, and new 2.
Wait, can I ask a question real quick?
Mm-hmm.
So is the body like a bit of code that it's going to run?
Yep. So this allows you to write code in yourself. You can do it, if it's short code, you can write it in as a string without having to make a separate file for it. But it basically reads this body as if it's the body of code. So it will take in your inputs and plug them in here, and then your output will be returned.
Holy smokes, that's crazy.
It's really neat. Okay, I need this to work. I think it's going to give me an error. It is. Okay. Well, I'm going to plug these in anyway. Let me try and make a new custom function node and see if a second one will work for whatever.
Does it like deselect right as you click on it?
Possibly, but even then it should be. I should be able to click on this and it turn into a text box.
Oh, no.
Heck.
Have you tried typing at all when you click on it?
Yep.
Oh man. Okay.
It doesn't. And I've tried right clicking it as well. That doesn't. All right. Well, hopefully this will work on y'all's end. Alright, so carrying on, our vector 1 that's going into this is going to be our index of refraction. So you're going to go over here to your properties, you're going to drag in IOR, and then pull that right into that slot. So that should be our refraction. Now our refraction is going to pull into a transform. So one thing you can do to make a new node is you can try and pull a line from an output from an existing node, and it will automatically open up that menu. So I'm going to look for a transform node, and we are going to transform this from world space, because that's what these are set in. We're going to transform it to tangent, with our type being direction. So this is changing how it's looking at these vectors so that we can use it elsewhere. And it's going to continue yelling at me for this thing. Unfortunately, that's just a thing we're going to live with. And then to show you guys what this actually looks like, I can show you the finished version of this. So our transform node is going to be added. We're going to do an add node. I'm going to pull that into the B slot so it's on the bottom. Collapse these things. We are going to add it to. I'm going to pull from the add node. There's going to be a screen position node. So screen position, as expected, gives you the position of the screen, and it's used for things that involve looking at things. So this I've seen used a lot for, between this one and scene color, used for a lot of faking transparency, which is essentially what we're doing with this glass. So because of the way we're handling this, we are actually not really making this transparent. What we're doing is we're tricking the renderer. We're tricking it into rendering the scene and then going back and rendering this object, whatever our glass is, and using all of the things that are behind it as part of the color on it. So we're essentially pretending it's by making it see-through on our own. I'm giving just a second to check something on the original version of it. Because I wanted to see if there were any settings that I made, any changes that I made to the settings of the master node before we go too far.
This is really cool so far.
Okay, so on our PBR master node, we are going to set it up as a transparent surface. So we're not actually using transparency in this, but it still needs to be transparent in order to render properly. We're going to leave it, the rest of it as normal. So we're going to leave it with a metallic workflow. We're going to have alpha blend, and we are not going to have it be two-sided. So two-sided means that it renders on, you know how a plane renders on one side, but if you look at it from the wrong side, it's like it's not there? The inside of objects are the same way by default. They, if you go inside of a cube, you won't be able to see it because you're on the wrong side of the basis. So rendering it as two-sided makes it so that both sides will render. All right, so now that we've got that done, we are going to take our addition node. We're going to get the floor of it. So the floor is, trying to remember the explanation for floor. it's a mathematical function for I want to get you guys a proper for just a second. So,
Floor is basically just running
While
down,
you're looking
right?
that up,
so the
Brandon
floor,
says,
it returns the largest integer value that is less than or equal to the value input that is into it. So what happens is if this is a float, it will turn it all into int by rounding it down. It's functionally what it does. So what we're going to do now is we are going to subtract the original number. We're going to subtract the floor from the original number. So the addition node goes into A, and the floor goes into B. So this will give us essentially the remainder, any decimal between that would be on these.
I'm going to bring this up in case it becomes relevant later. Brandon says he could actually not change the names. It lied to him. It just auto-fixed itself back to new. That makes it easier to follow along, I guess. I don't know.
Okay. I will do what I can to figure out a fix to that after we finish putting together this whole thing. But in the meantime, we'll just keep going and pretend like it's actually working like it.
Thanks.
Okay. So our subtract node is going to pull into, so what we've got right now is a transform.
You cut out.
Scene color node.
You cut
So
out.
the scene color gets it essentially gets an image of the scene as rendered without this particular object. So all of this fun math was to make it so that our scene will render onto our object as expected depending on the angle that we are looking at it, in addition to the angle of the object itself. So when you're looking at a flat plane that is directly parallel to you, it's going to look different. It's going to refract the scene differently than one that's at a 45-degree angle. So that's what all of this fun math was to get us to this scene color node. So all of this, what I'm going to do now is a very fun trick that I have discovered for organization. Select all of these nodes, right-click it, and click Group Selection. Now I'm going to name it Refraction, because that's functionally what all of this does. And now we have this neat little group that we can move around, and they don't get all, you don't have to try and select exactly the right ones. You can still move them around inside their group and treat them as if they're still everything on this shader. But this just helps keep them all together, all nice.
Organization.
So our next part is what we're going to be doing is when you look at a piece of glass, you can see through it, but you've ever seen at just the right angle it actually reflects things back to you instead of refracting it. So like especially when it's dark outside and your window just reflects your face at you, things like that. So we're going to get that little bit of edge reflection. And this one's going to be a very simple group. We're going to take our scene color node. We're going to pull it into a lerp node as our A. So we're going to be lerping between our refracted view of the scene. So this is everything that's behind this that our transparent glass is going to be seeing. Our B is going to be reflection probe. So there's a reflection probe node that finds the reflection probe that would be used in the scene that the object that this is on would be referring to. So for this, we are going to leave all of this as default. Nothing to change there. And then our time for lerping these together, which determines where on the object it's going to do reflection versus refraction. This is going to be my favorite node. It's kind of the salt of shader graph. And that is our Fresnel effect. So this is where our Fresnel power property is coming in. So you can grab that out of our properties, drag it in, and pull that into the power. And otherwise leave this as is. So leave this as world space. So this will determine how close to the edge you have to be to get a reflection instead of a refraction. That's what our Fresnel power is going to determine. All three of these nodes, I'm also going to group together. Group selection, and name it reflection. So now we know what these go. Oh, and this one. There you go. So if you've got a node that's outside of a group, and you click on it and drag it inside of the box of the group, the box will light up blue, as you might have seen, and that will, whenever you release it, it's like dragging and dropping it into a folder. You're just dragging and dropping it into that group. So all of this right now, as it can be used to go ahead and make some glass. It'll be basic clear glass, but it will be glass. So if you wanted to, if yours functions, because I don't think the one that I've got is going to work because of the not being able to rename things on custom function. But if yours works, you will be able to pull this into the emission slot on your PBR master node. That's this one here. And you can go ahead and pull your color into the albedo because that's just where that's going to live. It's not going to really change anything. And then if you do that and go back to your scene, hit shift+space to make that not be giant anymore. If you do that and go back to your scene and you have an object that you wanted to test on, so for example, what I will use is I'm going to use that crystal that I posted in announcements. There's also all sorts of LowlyPoly assets that this will work with. So then I'm going to go back to my shaders folder. I'm going to right click on my glass shader and hit create material. Oh, there it is. About a third of the way down, for me at least. Create material, and that will automatically create a material for me based on this shader. You could also create a material without clicking on it. And then up here where it says shader, you could find your shader. So for ours, that would be under shader graphs, glass. Either one will work. I'm going to drag that onto the. Now for us, it's not exactly working. Probably mostly because we have compiler errors, essentially. However, if I were to show you what this should look like, I can show you this. Sometimes it takes. There we go. Okay, so at this stage, if yours is functioning properly, yours should, in theory, look like this. So it's clear, see-through, and you see how it's refracting the world behind it. So these pieces of wood are going sideways in some of the faces. Here is the legs of this light sand back there. So right now we've got a functional glass shader, and it looks pretty neat. But we're going to make it even prettier. So to do that, we're going to do a couple of different. Over there, please. So first, we're going to make our pretty. We're going to make our iridescent. For this, we're going to start with our continual favorite, our Fresnel effect node. We're going to just leave the power of this one at 1. because that seems to look just fine. If you would like, you can make another property of a vector 1, name it something like color Fresnel, and pull that into power so that you're able to customize it. For me, I find 1 works fine. We're going to pull this now into a 1 minus node. A 1 minus node does kind of what you would expect it to from the sound of it. It takes in the input and outputs something that is 1 minus whatever is given. So with the Fresnel effect, this out here on the edges is white, and that means 1. Everything on the inside is black, means 0. So when you do 1 minus, you see it's brighter on the inside and fades out the closer it gets to the edge. Now our 1 minus node is going to add to something first. So we'll start down a little bit lower. Oh wait, let me make it. There we go. It's a little better. So we're going to start with, or continue with, a simple noise node. Now, a simple noise node is kind of what it sounds like. You've all seen noise textures before. What we're going to do for ours is we're going to pull in our Hudathunk. We're going to pull in our noise scale property and pull that into the scale part of that. So for us, it looks something like this. It's because our noise scale is small, it is at 10, so that zooms it in a good bit. Now this simple noise node, we're going to add it to our 1 minus node. So what this does is it essentially takes this noise and wraps it around the object, because the Fresnel effect node covers the whole object, and it's adding it to the 1 minus. So that is making it so that everything towards the edge that was black is now going to be a little bit brighter, because it's adding to whatever number essentially is returned by the noise node. So the numbers for this is also going to be 0 to 1, 0 being black, which might be something close to this down here in this corner, 1 being white, which is going to be something probably up here. Now we're going to do an interesting node that I'm very glad that I discovered existed, because it helps with a lot of things. We're going to get a branch node. So I'm just going to hit space to pull it up. A branch node is an if statement. So you pull in a predicate. So for us, that is going to be, is iridescent? No. For us, this is going to be uses noise, because this is determining whether or not we're using noise to scatter our iridescent around. So you pull this Boolean into our predicate part. If this is true, we're going to use noise. So we are going to pull from this node where we added this in. However, if uses noise is false, we're not going to pull from this. We're going to pull from the 1 minus node directly. So this will allow us to use the inspector to toggle this Boolean to determine whether or not the shader is going to use noise, or the material is going to scatter the iridescent. So this gives us our UVs. That's what the Fresnel is used for frequently. It ties into the UVs of the object. You use it to determine where on the object certain things are happening. So for this, we are going to pull this into the UV of a sample texture 2D node. So that's going to be, if you just type in the word sample, it's going to be at the bottom. It'll be sample texture 2D with UV out to the side, because that is where we're pulling this into. And for our texture, we are going to pull in our texture property. This will allow us to control the texture of the material from the inspector. So if you wanted to change it to a different gradient or something else altogether, then you'll be able to control that from the editor itself. Oh, I'm going to check VC for just, I haven't looked at that.
Nothing super important, just people being silly. Brandon was able to get it to work. He did it by clicking, typing, and then pressing enter.
Hooray.
Yeah.
Okay, so now we've got our texture that is being applied using our noise and our Fresnel to place it on the object. It's going to look interesting. I'm not quite sure how to explain it until you see it on the object itself. But using the Fresnel node essentially takes the rainbow and wraps it around the object so that, like if you're looking at a sphere, one end of the rainbow will be out towards the edges. So for ours, it would be, what colors did we do? I think it goes from red to blue. So like around the edges, at the far edges of the sphere, it might be red. And as it gets closer to the middle, it would be blue. I think I might have that backwards. Oh, I don't have that backwards because, if I'm not mistaken, the left side of the image is 0 and the right side is 1. But because this particular gradient, this rainbow gradient, goes from red to blue, it looked a little funny for the blue to be around the edges. So that's why I did the 1 minus, is because it looked better for the red to be around the edges and the blue to be in the middle. So if you had a gradient that was swapped in direction, you would probably leave out this 1 minus. But because of the rainbow that I selected,
Got a quick question.
This sample texture 2D, we're going to pull this into an add node, and we're going to add 1/2 to everything.
Right. Meg'n, are you deaf?
Remember there being an important reason for that, but off the top of my head, I don't remember why. So take my word for it that it looks better, I guess. And that will be it for our iridescent. So we're going to go ahead and group these together as well. I'm going to name it iridescent, if I can spell it right. I think that's right. Yeah, that looks better. So now we have 3 whole groups. How does this one tie in, though? That's where we get to next. So for this, we've got just a handful of nodes left to do. I'm going to pull this a little closer over here. And I'm going to collapse that for a little bit more. So we're first going to make another branch node. We're going to do this because we want to be able to make the decision of whether or not the glass is iridescent. So for this, we're going to pull in our iridescent pool and put that in as the predicate. There we go. And if it's iridescent, or I guess I should say if it's not iridescent, we're going to pull our original lerp into it. So for when it's true, what we want to do is we want to multiply our refraction. There we go. We're going to multiply that by our color. So typically getting things to become colorful is done by multiplying. So we're going to take that, pull that into true, and take the out of this, put that in emission, and we should be done. That should be our entire glass shader. So looking at the scene from the original version that I made, if you put it on something like this piece of glass, this piece of crystal, and you make it iridescent, now you see it's got some color to it. It makes it shiny. You can also change the color of it. So the customization of this is a lot of fun. So if you change the color, you can see it's still see-through, but it's a little tinted. White is pretty. It makes it real kind of foggy looking. Or you can get something like yellow or green. Dark blue or purple is pretty. But black is kind of your default. When you're doing scene color things, if the color is black, it shows through the best without interference from color. So your Fresnel power, this changes your reflection. I find it best to set it at 0.99, although for whatever reason, it's not letting me type in anything here either. I don't know what's up with Unity and not letting me actually type. That's weird. You can also change your index of refraction. So if you watch, see how it changes when it's at 0. When it's at approximately 0, there we go. 0 means no refraction. So it just shows through in the exact spot, makes it sort of ghosty. The smaller you get it, if you go below 0, it starts to invert. So it's, if I'm not mistaken, if I put it on, I'm going to put it on a sphere. It's not like to pull material onto it. If you take the index of refraction and bring it down, oh, right. Okay, so see how it starts to sort of loop around at the tops and bottoms of this? If you go much lower than 0.37, that starts to become really obvious and starts to look a little weird. But if you bring it up above 1, that's when things flip upside down. Or up above 0. So now you can see everything sort of upside down in this. It's a lot of fun to play around with. I like to keep it at about 0.3 something. So for now, power is, see if I can get it to show up. There's somewhere around here, I had it where you could see the sky show up at a, but it's hard to get that to show up on this. Oh, actually, there it is. You see on that might not be. Never mind. Wait, no, that is. Okay, so you see on the edge of the sphere right here. This is our reflection. So it's reflecting the skybox once it hits that edge, instead of refracting all around it. We also have our noise scale. Oh, actually, yeah. Let me show you what it looks like without noise. So without noise, it actually looks kind of predictable in that the edges that are closer to being perpendicular to you are more red, and the edges that are closer to being parallel are more blue. But if you turn on the noise, kind of shakes things up a little bit. Kind of makes it a little harder to guess where the color is going to be. Changing the noise scale changes where those colors change. And as the noise scale gets bigger, you can kind of see now the different colors are not just along the edges. It's not per face. And you can see it really well on the sphere. You see how it gets all sorts of wibbly wobbly. The higher it goes, the more it starts to look kind of like an oil slick. Or you can turn iridescence off altogether. I'm going to check on PC now because I haven't looked at it. Okay. Oh, is there a way to modify the shader variables on a per item basis? kind of. So all of the objects that use the same material, when you change the material, it's going to change it on all of the objects. One option is to create a separate material for each object, which can be a bit of a pain depending on how many you want to. However, if you make changes to the material in a script, you can have it make an instance of the material in the script. So that way, in your assets folder, there won't be 17 different versions of the same material, but whenever it's running, it will temporarily create a new version. So that can still be a little more performance heavy, I guess, but I don't think it would be super noticeable. Actually, if I'm not mistaken, Rib, that's how you got it to do, or I'm not exactly sure how you got it to do, but something you did whenever we had the dissolve shader in IO, how it worked differently for each enemy, so that the enemies would dissolve at different times. That would be the same sort of thing.
Oh yeah, I forgot how I did that.
Oh, yeah. Okay, so there's also, yes, there's a time node. Or, so there's all of these things here that are the properties, that's the word. All of these properties that are in the inspector are exposed. So if you go back to these properties here in shader graph and you look at them here, the very first thing is a checkbox that says exposed. Exposed means it's essentially making them public. So what that does is it makes it show up in the inspector, but it also makes it so that you can access them via script. So what you can do is, if you wanted to have this change over time but not necessarily be tied to time itself, you could write a script that would change that variable whenever you want it. Okay, are there any questions that I missed, or any other questions that anybody has? Oh, mostly from YouTube. Having a question, thinking, man, wouldn't it be cool if I could make something that looked like that? And then Googling to see if anybody else had. Most of my things that I've made have been kind of Frankenstein to. For example, this glass shader, for the glass part itself, I followed, I think, 1 or 2 different tutorials to get the effect that I wanted. And then the iridescence was a third, at least 1 more tutorial. Back when I did it, it might have been something that I pulled from not shader graph, but tutorials in making shaders themselves. If you can understand at least a small degree of the shader language, you can kind of look through tutorials that people have written for shaders written in shader language in HLSL and try and figure out exactly which nodes you need to recreate that. Yeah, definitely the club helping me turn it into English, because trying to explain things to other people makes you learn it a whole lot better than trying to just learn it yourself. Once you think you've got a handle on something, try and teach it to someone else, and you'll figure out just how much you know, just how much you don't know, and you'll realize that you now know a lot more than you knew before. Since it was brought up, I kind of want to try and make the noise move. So I'm gonna walk through that as well. So for this, what I'm gonna do is, I know the first step's gonna be a time node. And the time node does kind of what you'd expect, and I used it in the last time I did this about a year ago. But the time node gives you the current time or sine time. So over time, it goes back and forth between 0 and 1. Cosine time, which is offset instead. I think it's not quite the opposite of that. You know what sine and cosine look like. Delta time, the time between frames, where you would use this in code anywhere that you would use this here as well. And then smooth delta is delta time, but so you can take the time node and you can try hooking it up to the UV, but that makes things a little erratic. As I've discovered, I've tried that a couple of times. Every time it's not quite what I want. So what I like to do, I like to make a tiling and offset, and then pull the time into the offset of that, and pull that into the UV, and that makes it scroll. So if we hit save asset, oh wait, this is the wrong one. This is the one that doesn't work. Let me do that again, but in the one that does. So we do time into a tiling and offset as the offset, pull that into the UV, and it takes a minute to load. Hit save asset, and then go look at it in the scene. And now you can see it's wiggly. It's very wiggly. If you want to adjust the speed of that, what you'll do is you make a property, a vector1, call it speed, and then you wait for your computer to sit there, because especially when you've got a lot of things already in the shader, shader graph does not like to make new properties very quickly. Now we have speed. You're going to pull that into the scene. I'm going to multiply your time by your speed, and then pull that into the offset. And you're probably going to want to default this to something like 0.5. And then save your asset, go back to the scene, wait for it to load again. Shader, there we go. And it's a little slower. And now we can adjust that to make it, oh, don't go negative. Negative, it goes too fast. Ah, there we go. Now it's really slow. Or a little faster. Or like, you can get it to whatever speed you want it to be. So time is a lot of fun for making animated material. Now, if you did this on your computer and it didn't work, if you look at it and it's not moving, what you need to do is you need to go to, I think it's this thing here, where it's got two little planes with a little star on it. See the arrow next to it? You're going to want to click animated materials and make sure it has a checkbox to it. Because if you turn that off, all your animated materials will stop moving. Makes it a little easier to look at your scene when you've got a lot of materials that are animated, but if you want to see how they actually look in the game, you're going to want to turn that on. And now they move. Alright, well, it is 7:37 now. That did take the entirety of my time, so if you guys would like to do showcase, now is the time. I think that is all that I have to show. I can post the code for the shader if you guys would like. I can post the file for it in announcements, as well as anything else. I have some screenshots for those who weren't able to follow through or might have gotten lost. So just let me know if you guys would like to do anything. But other than that, I think I'm going to go ahead and pass it on to Rob to handle showcase.
Awesome. All right.